Hello friends, welcome to Susan and John MathTube. This is Multiple Integrals lesson number 6, and in this lesson we learn how to evaluate double integrals in polar coordinate system. Okay, I'll give you a small introduction to polar coordinate system. Look at this. If you want to capture all the elements in a plane, normally what we do is we draw two lines. And one line will be called the x-axis and another line will be called the y-axis. That is, we are dividing the plane into four different parts. And by calling this as the positive x-axis, the positive y-axis, negative x-axis, negative y-axis, we are actually able to give a unique representation. We are actually able to give a unique representation to each and every point on the plane. For example, if you want to locate this, all you have to measure is the distance from the origin to this point, and generally we call it x, and the height from this point in the y direction, and generally we call it y, or rather every point will be in the format x comma y. So I'll repeat once more. In Cartesian coordinate system or the rectangular coordinate system, the name rectangular coordinate system comes because every point can be associated with a rectangle. Every coordinate, look at this, in the plane there are so many points, infinite number of points will be there. But with this method, every point will get a unique location, kind of like an address. So every point in the plane will have a location. Now comes another system, the polar coordinate system. In polar coordinate system, instead of drawing this x-axis and y-axis, what we do is we just draw one arrow. And this point will be called, look at this point. Instead of the origin, we have a point here, and that point is called the pole. And this is called the polar axis or the initial line. Now look at this, same story. The plane has infinite number of points. Let's say, I'll put reference, let's say plane is infinite, so I should not put any boundary. So please understand, plane is infinite. Okay, I'll put a boundary here. But please understand, plane is infinite. Okay, now there are many points as I referred before. But using this technique, what we do is, we for every point, for corresponding to every point, we will measure the distance from the pole and this angle. And normally the distance will be denoted by r and this angle will be denoted by theta. So every point comes with a representation r comma theta. So remember, if you want to locate this point, then all you have to do is you have to measure the distance from the pole, and then you have to measure the angle starting from the initial line, and that's it. The name will be called r comma theta. Now, corresponding to every representation in the Cartesian system, there will be a representation in the polar system. For example, you can focus on this point, and we have the Cartesian system, so the name goes like x comma y, or in other words, the distance from origin to this point is x in this direction, and in the y direction it will be y. Now let's imagine the positive x-axis. Let's imagine the positive x-axis to be the initial line, our polar system. I told you, if you want to draw something in the polar system, we do not draw x-axis, y-axis, we just draw an arrow. And let's assume I'm drawing that arrow starting from origin to in the positive x-axis. That means this point will be serving as the origin in Cartesian system and pole in the polar system. Now in polar system what we do is we measure directly. So we measure this and we measure this angle. So the name will be r comma theta. So remember, this point will be called x comma y in the Cartesian system and r comma theta in the polar system. Now if you want to connect them, I'll repeat once more, these are like two different languages. It's just translating one language into another. So if you want the relation between them, it is very easy. You can see a right angle triangle here. If you use Pythagoras theorem, you get the relation r equal to x square plus y square. Now, if you calculate tan theta, you get y by x. If you calculate cos theta, you get x by r, and sin theta gives y by r. Okay, that's it. Now, I will make you understand the importance of this. So, r equal to root under x square plus y square and theta is equal to tan inverse y by x. This tells me, given any coordinate in the Cartesian language, I will be able to convert it into the polar language. I will be able to find r as well as theta. Actually, you have learned this in complex numbers in class 11. And in complex numbers, you used to call this modulus argument form. You might remember now, in class 11, this is exactly what you were learning. Okay, now look at the last two expressions. X is equal to r cos theta and y equal to r sin theta. Now look at this. This gives me the confidence. Given any point in polar language means the distance from the pole and the angle will be given. I will be able to translate it into the Cartesian language. That means I will be able to find x and y. Now, one more thing. Every picture in the Cartesian plane, for example, you learn that x square plus y square equal to a square is a circle. If you transform it into the polar language, it will look different, but the picture will be the same. X square plus y square is, I think you saw x square plus y square here. So look at this. R square equal to a square, or rather r equal to a. Okay, so this is the polar language. So in polar language, you have to understand this represents a circle. Look at this. Here it represents a circle with center, origin and radius a. Here in the polar system, what happens is r equal to a means let theta be 0 degree, let theta be 90 degree, 10 degree, 20 degree, 30 degree, it will be a. So this is the corresponding figure. And I want you to note this. Because in the exam, if they give you r equal to a, you should be able to recognize it's a circle with center pole and radius a. Okay, now you can note one more thing, that is r is equal to a cos theta. Remember, r equal to a cos theta also represents a circle. If you want, I will transform this into Cartesian and show you. In Cartesian, x square plus y square plus 2gx plus 2fy plus c equal to 0 represents a circle with center minus g minus f and radius root under g square plus f square minus c. I am sure you learned this in class 11. Now look at this, r equal to a cos theta. So I am going to transform this a into, I am going to find the value of cos theta because we learned the transformation. What is cos theta? X by r. Now cross multiply, we get r square is equal to ax. That is x square plus y square equal to ax. Or we get something like this. Or look at this, x square plus y square minus ax plus 0y plus 0 equal to 0. See, it's a circle. So remember, in Cartesian language, the circle looks like this. In polar language, the circle looks like this. But remember, a circle will always be a circle. And the radius cannot change. Okay, now look at this. I want you to draw r equal to a cos theta. So we have our pole and we have initial line. If I plug in 0 degree, cos 0 is 1. So I get a in 0 degree. So it goes like this. And if I plug in 90 degree, I'll get 0. So I can understand very clearly that the circle goes like this. You can by heart it, or you can plug in different values and plot it. You can put 30 degree, 45 degree, 90 degree, etc. and plot it. But for the exam, it will be better if you by heart it. So r equal to a cos theta is a circle, and the diameter, this will be the diameter. The initial line itself will be the diameter, will be a units. And finally, I want you to be introduced with the circle r equal to a sin theta. So this is something like this. Because when you plug in 0, you will get 0. When you plug in 90, you will get a. And it goes on like this. And to be honest, you have to be familiar with all the polar equations which you learned in first semester, first part. And I have a video in areas, and in that video I explain all the polar pictures. You can go through it. I'll provide the link in the description. Okay, now 2 more pictures. In this video I'll provide only the necessary pictures. So the next one is r equal to a into 1 plus cos theta. This is a very famous picture. This is called the cardioid, and it looks like a heart. And the picture goes like, that's a very easy method to learn. You put 0 degree, you will get 2a. So I know that the cardioid will be something like this. And this is 0 degree, this will be 90 degree, and this will be 180 degree. R is equal to a into 1 minus cos theta. And this is also cardioid. But here what happens is, when you plug in 0 degree, you get 0. And when you plug in 180 degree, you get 2a. So the cardioid goes symmetric in this manner. Okay, you can draw a little bit neatly. Okay, now let's try 1 or 2 problems based on polar but multiple integrals. So you can write the question: evaluate the double integral r sin theta dr d theta, and the region of integration is given. The region of integration is the cardioid r equal to a into 1 plus cos theta above the initial line. So we have to evaluate this integral within the cardioid, but it will be above the initial line. Okay, I told you one thing: you should be very good with polar equations. Just like you're good with Cartesian equation, you should be good with the polar equation. I'll provide the link to the first year first part video in the description. You can check it. We have the initial line here, and you can draw a rough picture of the cardioid. Okay, now it is clearly mentioned we are interested only in the upper part. Okay, now one very important thing is, when we evaluate polar integrals, we do not draw vertical strip or horizontal strip. Instead, we go for angular strip. Look at this. I think you can see a small arrow moving like this. So my job is to find the length of the arrow and the angle through which it rotates. One easy method is you keep your pen like this. In the exam, you keep your pen like this and you can measure the angle very fast. So this is 0 degree and it goes 90 degree, 120 degree, 130, 140, 150, 160, 170, 190. So I am going to write theta varies from 0 to 180 degree. Or I am going to write in radian measurement, theta varies from 0 to pi. And if you want, in the exam, you can show a small angular strip. In the exam, you can show a small angular strip. I guess that's okay. Now, as I told you before, I have one more thing to do. I define the length of the angular strip. Okay, for that I'll show you one trick. So look at this, the length keeps on varying. The length keeps on varying. You can follow the arrow. You can see the length keeps on varying. And I can see that the length starts from the pole to the cardioid. The length starts from pole to the cardioid. You can draw the strip anywhere. My arrow shows it very clearly. Length will be from pole to cardioid. Pole to cardioid, pole to cardioid. So I'm going to write the limit of R. So what can I write? R varies from pole to cardioid. But at the pole, the value of R will be 0. And when we reach the cardioid, R value will be A into 1 plus cos theta. Okay, so everywhere we are moving from pole to cardioid. Now look at this. This means all the points in the cardioid will be captured. Because I am moving or I am sweeping. I am sweeping from 0 to pi. At the same time, I am covering every point. Okay, that's it. Now it's time to integrate. So we found theta varies from 0 to pi and R varies from 0 to A into 1 plus cos theta. Now I am going to write the integral will be double integral R sin theta dr d theta. Now wait a minute. In polar integrals, since in most of the problems angle will be in numbers, constants, we tend to write theta here. And R will come as the inner integral 0 to A into 1 plus cos theta. So this makes sense, dr d theta. And for your advantage, our old method. Now we are ready to integrate. When we integrate with respect to R, our sin theta will be a constant. So I am going to keep sin theta and R means R to the power 1. That gives me R square by 2. And R changes from 0 to A into 1 plus cos theta d theta. Now what happens? I am going to keep this 1 by 2 outside. And theta will be 0 to pi. And I am going to plug in, okay, I will circle as usual. Here the plug-in variable is R. And you have to plug in the upper limit first. Anyway, I will write sin theta, otherwise I might forget sin theta. So A square into 1 plus cos theta the whole square minus 0 square. Now this is very simple integration. I hope you remember what to do when you get a function and a part of the derivative together. You know that cos theta, the derivative is minus sin theta. Anyway, minus sin theta is not here, but sin theta is here. So remember, when this happens, the best method will be substitution. So I'm going to put 1 plus cos theta is equal to t. Because I know that the differential of 1 plus cos theta is over here. I take the differentials. So minus sin theta d theta is equal to dt. So that I get sin theta d theta is equal to minus dt. I'll color it so that later I can use it. Now, one more very important thing which I've seen many students forget in the exam. Look at this. The given limit belongs to theta. The given limit belongs to theta. It doesn't belong to t. We are transforming everything into a new variable, namely t. I'm going to write the transformation once more. T equal to 1 plus cos theta. Now I'm going to check. If theta is equal to 0, then t will be 1 plus cos 0. That is going to be 2. And if you don't know the values, use a calculator, but make sure when you plug in pi by 2, etc., which is default in your calculator, make sure your calculator is in radian mode. Otherwise, you will get an answer, but the answer will not be correct. I'll repeat once more. Those students who are struggling to by heart the values, no need to worry. All the values are set default in your calculator. But remember, your calculator should be in radian mode before you type cos pi. Anyway, if cos pi is minus 1, the answer will be 0. And we get a square by 2. I'm going to plug in the new limit 2 to 0. And 1 plus cos theta is t. So we get t square. And this is minus dt. Okay. I'm going to interchange the limit. So can you tell me the punishment for interchanging the position? A very simple thing. You put minus. Minus will be plus. So I'm going to write dt. So this minus is gone. Now time for integration. So we get a square by 2, t to the power 3 by 3, which you can handle. T is from 0 to 2. And simplification should give you 4a cube by 3. So that's it, my friends. So I'll be back with a few more problems in polar in the next video. And after that, we'll be dealing with change of order and change into polar. So till then, my friends, bye.